So if you factored these, this is just a snippet of the top part of what you guys were doing. When we factor this one, what do we get? What multiplies to be 121 and adds to be negative 22? Minus 11, minus 11. So since both are the same, we could rewrite this as x minus 11 squared. And that turns out to be true for all of these. They are what we call perfect square trinomials. The trinomial, a three-termed polynomial here, can be factored and it's a perfect square. So it always can be written as, something squared. So this one would be x, what? What multiplies to be 144 and adds to be negative 24? Minus 12. What's this one? Plus 3. Plus 11. What's this one? Okay, so that's a pattern. They're all perfect square trinomials. But I want you to look even deeper for more patterns. Take this one, and this one, and this one, for example. And tell me how you could explain or describe to somebody the relationship between the middle term and the last term in all of these. The same for all of them. The middle term to the last term. What is the relationship? Yeah. Okay. So they both have 11 in common, is what you're sort of saying, right? It adds to be the one and multiplies to be the other. Okay. So how could you describe that situation? Like, what could you do to the middle term to get the last term? Maybe I should word it that way. Yeah, Ella. Good. Half of the middle term squared will give you the last term. You guys see that? Right? If we take half of 22, we get 11. Square it, and we'll get 121. Half of negative 16 is negative 8. Square it, and we get 64. Half of negative 6 is negative 3. Square it, and we get 9. So not only is half the middle term squared give us the last term, but when we do half the middle term, that's what shows up in our parentheses, right? You guys see that? Okay, so those patterns and things that happen in the perfect square trinomials are going to help us with this next part that we need to learn how to do. So just for the purpose of this video, this is the circles packet 5.7. We're on like the third page, and we're continuing with 5.7 notes. Okay, everybody with me? Okay, so if I gave you an equation that looked like this, is that a linear equation? You're all saying no, but actually it is. It has x and y. That's all it takes to be a linear equation. You're saying no because it's not in a recognizable form, right? It's not in standard form. It's not in slope-intercept form. But could we put this into one of those forms? Yeah, and then it would graph a line. So is it a linear equation? The answer is yes. It's just not a real nice one where we could look at it and be like, oh, the slope is this, and I can graph it easily. We would have to rearrange it first, right? Okay, so similarly, this is the equation of a circle. because it has an x squared and a y squared. And the equation of a circle has an x squared and a y squared. But if I asked you what the center and the radius of this is, would you be able to tell me? No, because it's not in the right form. So our job here is to put this into the right form. Eventually, we want this equation to look like this. Right? That is the correct form of a linear equation. Sorry, equation of a circle. I said linear, but I meant equation of a circle. So we are going to do what's called completing the square. Now, completing the square is literally completing a perfect square trinomial, which is what all of these are called. These are perfect square trinomials. When you factor them, you get something in the form of a binomial squared. So since we need a binomial squared here and a binomial squared here, we're going to take this original equation and we're going to complete the squares so that they factor to give us the right form of a circle. All right? So how do we do that? Well, we are going to first group our x terms together. So we're going to write x squared plus 8x. And then I want you to leave a blank. And then we're going to have plus y squared minus 2y. And again, leave a blank. Equals 64. With 2 blanks. Now, look at this as a perfect square trinomial like we had up here. We said in order to get this last term, what do we have to do to the middle term to get the last term? Cut it in half and square it. That's how we get the last term from the middle term. So we're going to cut positive 8x in half. What do we get if we cut positive 8 in half? Positive 4. Well, we can actually put that into our parentheses down here. But then we have to square it to get what goes in here. What's 4 squared? 16. Okay, remember when we said up here, right? Cut this in half, square it, and you get the last term. But when you cut it in half, that's what went into the parentheses. So we just did the exact same thing here. We cut positive 8 in half, that went there. Square it, and that is what you add. Okay, we'll do the same thing for the y's. Middle term is negative 2. Cut it in half, what do we get? Negative 1. And the sign matches, right? If it's a negative 2, you cut it in half, it's a negative 1. Now square it. Negative 1 squared is positive 1. Notice that even if we're squaring a negative, it's still positive. So the two things in these blanks are always going to be adding. It's always going to be plus, the numbers. Okay, well that's really convenient. We just added a 16 magically in the right spot, and we were able to factor it as x plus 4 squared. And then magically we added a 1 in the right spot, and we were able to factor that into y minus 1 squared. So really nicely we have this part of an equation of a circle. We could now get the center. What's the center of this circle? Negative 4, positive 1. But we still have the radius that we have to deal with. So why did I put a blank here? Yeah, because this equal sign right here is not just there for decoration. An equal sign literally means the left-hand side is exactly the same value as the right-hand side of this equation. Well, we took the left-hand side of this equation and we very conveniently added a 16 and a 1 to work to our advantage, but we've upset the equal sign, right? If you add 16 and 1 to one side of an equation, well, now we don't have an equation anymore. It's not equal. So in order to fix the situation, we have to do the exact same thing to the other side. Okay? So we added 16 and 1 here. We want to add 16 and 1 here. Whatever you do to one side, you got to do the exact same thing to the other side. So now we have 64 plus 16 plus 1, which is 81. So we've now completed our circle equation. And what's the radius of this circle? 9. Okay, so we're going to do one more together, and then I'm going to let you practice on your own. The process basically, and the steps are written out on the back of this packet, but the process basically, in your first step, what you want to do is collect your x's together, leave a blank, collect your y's together, leave a blank, and get your whole numbers or your constants to the other side of the equal sign. So in this one, we actually do have to subtract 120 from both sides, because we want that whole number, that constant, to be on the other side. Remember, we subtracted, so it's a negative 120 now on the right-hand side. Now we're going to group our x's together. X squared plus 2x, leave a blank. And then y squared minus 24y, leave a blank. And don't forget the blank blank on the other side. Now we're going to take the x's and do our magic here. What is the half of the middle term? 1. That goes down here. Square it. Add 1. Again, do our magic. Half of the middle term, half of negative 24 is negative 12. Square it. And what are we going to add? 144. So whatever we do to the left, we have to do to the right. So we're going to add 1 and add 144. Now remember, it's a negative 120. So we basically have 145 minus 120, which is 25. Here is the equation of our circle. And the center is at negative 112, and the radius is 5. Okay, I'm gonna have you guys try C and D on the back. Okay, for this first one, you should have gotten x squared plus 24x, add 144, plus y squared plus 6y plus 9 equals negative 137, and then add the 144 and the 9. Your final answer then was x plus 12 squared plus y plus 3 squared equals 16, which makes our center negative 12, negative 3, and a radius of 4. Remember that the original formula is x minus h, right? So the center is always opposite signs, kind of what you see in your equation. Since this was x plus 12, it gave me a negative 12 at the center, etc. Okay? And part D, x squared plus 8x, you had to add the 16. And then y squared plus 32y, you had to add 256. And it's negative 263 plus the 16 plus the 256. Your final answer comes out to be x plus 4 squared plus y plus 16 squared equals 9. The center is negative 4, negative 16, and the radius is 3. All the steps are written out here. They're like typed out. If you get stuck, that might help you to refer to that.